Hello and welcome. Today I'm gonna walk you through in creating a 3D model using the Solid Edge environment software, and later I'm gonna show you how to export the model we're gonna create into an STL file, which we can later use to create a 3D model on the 3D printer using the 3D printing software. So the goals of today's exercise is to show and learn and teach you how to log planes, how to draw basic shapes and modify them, how to use measuring tools in Solid Edge environment, how to extrude objects, how to create cylinders and holes, and how to center objects. So let's get started. Our object, our 3D model that we're gonna create looks like this, and we can see we got diameters, we got radius, and we got different shapes and hole sizes that we need to create. So I'm going to walk you step by step in how to create this 3D model. Okay, let's continue. First thing that we need to do is to choose the proper option in Solid Edge environment. So I got Solid Edge over here, and we need to choose new and isometric part. When we select this, our working sheet will open. Okay, and on the pulpit we're gonna see three axes. That's X, Y, and Z. And I'm going to show you in a second how we will utilize and operate in this environment, because our object will need to be in the 3D space. Okay, so let's continue. We mainly will be using the sketching tab, and also the mainly sketching tab. Okay. So what we're gonna do? First thing that we need to do is to show and learn how to log planes. Basically, we need to start by creating a 2D object and then extrude it to give it like a depth. So how we do this? First, from the sketching tab, we choose the line, and we have to log on whatever three of the planes we like. Let's say for this exercise we're going to choose the plane ZY. So if we put the mouse pointer in this area, we're going to see a lock and the F3 symbol. So there are two options. Either we're going to choose F3 or just a click on the lock. Okay, and then we'll see a black square. Okay, now we're going to go in the front, so we're going to see the black square like this, you see. And now we locked the plane in this space, so ZY. Okay, and everything we're gonna sketch now will be sketched on this plane ZY. Yeah. So let's continue. Okay. So as we see in the tutorial, we already locked the plane. And let's continue forward. Okay, now we're gonna draw. This is the information that we can log planes or on either of the three axes. So now what we're gonna do? We're gonna sketch object, a square, and we're gonna give it the proper dimensions so we can continue further with our tutorial. Okay, so let's continue. We're gonna choose the line option, and we're gonna create a 2D simple object. As you see, when we rotate it, when I click the center mouse button, the wheel, and rotate the mouse, you can see it's already in the 3D space, but it doesn't have any depth. We're gonna take care of it in a second. Okay, so now when we choose the smart dimension option, we can check the dimensions of this object, okay? And when we get back to our project, we can see that the back of our main object that is over here has a dimensions of 70 by 100. So now we're going to create this one, and it's very easy in Solid Edge environment because we can edit these parameters. So we need 100. We click on the parameter, insert 100, and confirm it by enter. And as you see, we have a dimension of 100 millimeters, and now we're gonna correct the length. And the length of our object, according to our project, is 70 millimeters. Okay, so let's edit this to 70 and confirm by enter. And as you see now, we got a dimensions exactly as they're supposed to be in our sample project. Okay, and now when we go back to the place where we're now in the tutorial, you can see that we got an arc. We have to create this arc, this one, which has the 35 millimeter arc on the top side of this back portion of an object. Okay, and how we do this? Well, we have to use the option that's called arc by 3 points, and we're going to create an arc that has a radius of 35 millimeters on the top part of this object. Okay, how to do this? Well, it's pretty easy because we can use either the fillet option and give it a radius of 35, and once we click the two left corner lines, we will have the arc of 35, and then the same with the right side. You see, now we don't need this line anymore, and as you see, when we get the smart dimension, we got perfect arc of 35 from both sides. So that was the goal of this step. Okay, exactly as we see here, we use the option to create the arc with the radius of 35. Okay, so that is the option that's called fillet. Okay, and the other option is to take arc by 3 points. So I will go back now and show you how to do it the other way. Yeah, and order to do this, we need the 35. Yeah, because the radius is the same on all of the squares, so we create 35. Yeah, we draw a line, and now we use the option arc by 3 points. We click on the beginning, we click on the end, and we click on the top part, and that's it. So now we created the arc with a radius of 35 millimeters. We delete what is not needed anymore, so those lines. Yeah, and basically the effect is the same. Okay, so there are multiple options to draw different shapes in Solid Edge, and I just showed you both how to create the arc, sample arc, either by choosing the fillet and inserting the correct radius, or choosing the arc by 3 points options, and we created this. So the effect is the same, it's just a different option to achieve it. Okay, let's move forward. Now I'm going to show you how to extrude this object, because as you see, it's not yet dimensional. It doesn't have depth to it, and according to our object, it should have a depth of 14 millimeters. So how are we going to do that? If we press and click the wheel of the mouse, and we can rotate the mouse, you see that we moved it in the 3D space. So I'm going to leave it at the slight angle, click inside, and you can see there are two arrows visible. We click this one or this one, it's up to you. It's just showing the direction we're going to extrude it. Let's say we're going to extrude it to the screen. Yeah, so-called. So we click this one, and as you see, when I move the mouse, I'm extruding the objects I created in a minute ago, yeah, but I need the concrete measure of this extrusion. So I put 14 and confirm it by enter. Okay, and as you see, now we created the back plate of our object that has precise measurement of 14 millimeters of depth. Okay, and every time I need, because I can disable the dimensions because they're gonna be in the way of our object, of our project. So now I'm gonna clicking and deselecting and deselecting PMI will show and hide the dimensions. Okay, so that's PMI, and the base will show us and hide the indicator of the base I started from. Okay, so the axes. Let's hide them for now, and let's set in the center of the object we created. It's now a 3D object, yeah, but for now it's just the back part of my project. Okay, so now I have exactly the same thing. So I created the 100 by 70 object. I created an arc of radius 35, and I give the dimension, the depth of 14 millimeters, exactly as here. Okay, so now we're gonna quickly get back to our object, and we can see that it has a bottom part that's extruded on the height of 14 millimeters. So it's 14 by 14. So how do we gonna do that? And it's extruded 100 minus 14, 86 millimeters from the bottom part. So we're gonna do it now. Okay, how are we gonna do it? When we choose the line, we have to lock planes again, but this time we have to lock plane on this space, on the plane that's closest to our screen. So this one, we lock on this part and we sketch the line. Doesn't matter the dimensions now. Okay, and as you will see in a minute, I'm going to choose Smart Dimension to measure it. Okay, so it's 15, but our project said that it should be 14, so we're going to edit it 14 and enter. Okay, and as we said before, we need to extrude it again, same as before, but this time we're going to extrude only the bottom part, and it's 100 minus 14 again. That equals 86 millimeters. Okay, so we click on the bottom, extrusion again, and we insert 86 and confirm by enter. Okay, and as you see, we have the back part extruded and ready. If we insert PMI, we can anytime we can add dimensions. So I'm gonna add dimension now, 100 times 86, yeah, and times 14. Okay, yeah. Now I'm gonna hide it again. Okay, and now as you see, we moved forward, and now we have like a back and the bottom extruded part of our object. So it's this one and this one. Okay, let's get back to the place that we left the tutorial. Okay, it's exactly the same as I did in a second. So we locked the plane on the front part, we draw a line at the bottom, we edit it to 14 millimeters, and we extrude it to 86. Yeah, so that's exactly what we have over here. Yeah, now, and no problem, I can all the time rotate it, set it at the angle. Yeah, for now let's do like this and continue. Okay, now we have to extrude the cylinder. Yeah, and the cylinder have to be on the specific measurements at the specific center. So it has to be at the exact same place that the arc center was. Okay, and the dimensions are 36 millimeters. Okay, so it's gonna be 36. Okay, let's go back here. The diameter is gonna be 36 millimeters. Okay, so let's continue over here. Let's set in the front. Again, we have to lock on this plane, and we need to have a center. And the center, once we have all those options enabled, IntelliSketch will automatically show us where the center of this arc is. Okay, this arc is like a half of a circle with the radius of 35, and when we need this place, you see, as I move the cursor close to it, it's automatically attaching my cursor to it. So I click on it. Yeah, sorry, it's this one, circle by center point. Yeah, okay, here, and our diameter is 36 millimeters, and I confirm it. Okay, as you see, it still doesn't have any depth to it. It's just written like on the plane surface for now, but now I can extrude it again, and according to our to our project, it should be extruded to 30 millimeters. Okay, yeah, so we got a circle by 36 millimeter diameter. It's ready now, and now we have to extrude it. So we move it at the angle again, click in the middle, arrow, move the cursor a little bit left, and insert 30 millimeters and confirm by pressing enter. Okay, as you see now, we got the cylinder extruded on the 30 millimeters length and the diameter of 36 millimeters. You see? Okay, it's over here. Yeah. Again, for the dimension not to be in the way, we unclick PMI so they disappear. You see? And that's another step towards the towards our ready object. Another step, so it's cylinder creation. Okay, now inside of this cylinder, we need to create the hole that will go throughout the whole object. Yeah, and we have to basically do it the same as before, but now we're not gonna extrude it, but we're gonna go through to the other side of the object. Okay, so again, we're going in the front of the object. We have to draw another circle. Okay, this time the circle, we have a diameter of 20 millimeters. So same procedure, we lock on this plane on the front of the cylinder this time. Again, we're gonna click on the center and 20 millimeters and confirm by pressing enter. Okay, and it's exactly the same procedure. We create the slight angle, move it at the angle, click inside, and this time we're not gonna extrude it left side, we're gonna extrude the right side throughout the object. Okay, so let's click this arrow, move throughout, and just confirm outside by clicking a left mouse button. And now, if we rotate it, you see the 20 millimeter hole is created inside the cylinder and the back part of the object, just as we planned and just like the project is saying. Okay, it's exactly same procedure here. We just extruded the hole now. We didn't extrude the cylinder, we extrude the hole through the cylinder and the back part of the object. Okay, so that's exactly what we did here, and we're in the same place now. Over here, our object now has a cylinder and the hole extracted throughout. Okay, again, we can bring back all the dimensions and give the hole a diameter of 20, like this. Okay, and again, we can disable them so they not get in the way. Okay, like this. Okay, the next part that we need to do is a bit tricky because we need to create the coincident plane. What the coincident plane is, basically, we need to create the plane that can help us to draw a supporting structure, because we need to create the structures that's gonna support this, this cylinder. Because if we try to 3D print it like it's right now, it wouldn't be like this. We would have the printing errors, the incorrection, because it can't just be in the air. We have to have the supporting structure to it. Okay, so now I'm going to show you how to create the coincident plane. It's pretty easy. As you will see in a second, coincident plane option is over here. Yeah, we choose it, we click on the back part, and now you see the option to move the plane. Okay, so we click this one, this arrow, and we're gonna move the coincident plane to the center of our object, so of our cylinder. It's over here. Okay, and now you can see we have plane 4, and this plane 4 is exactly in the middle of our object, in the middle of the hole and in the middle of the cylinder. And everything that we will try to sketch right now, when we lock on this plane, will be over here. And that's what we need, because in order to create the rib, because next option will be to create a rib, we need to have this line to create this rib from something. Rib is like a supporting structure that will help us to support this cylinder, so it's not gonna fall down during 3D printing. Okay, so let's choose the line option. Let's lock the plane on our newly created plane 4, and then we can draw a line from here to here. See, that's what we need. Okay, this will be like a base to our rib structure that we're gonna create in a second. Okay, so to get over it once again, to create the coincident plane, we need to choose from home coincident plane, so it's this option. Yeah, click on the back part and move the plane on the middle of our object. Okay, and then we locked on this newly created plane 4, and we sketched the line from the bottom part of the cylinder to the bottom part of our base. Okay, just like it's here on the screen. So that's what we did. It's exactly what we did in a minute. Okay, a minute ago. And now what we're gonna do, it's pretty easy and it looks kind of cool. We're gonna create a rib, and according to our dimensions of our object, this rib have to have a dimension of 14 millimeters. Okay, so in order to do that, we have to go to solids, thin wall, and choose the rib option. Okay, so let's see. Choose thin wall, and the rib, you see, it's visible right now. It recognizes that there is a place that we can create a rib on. So we choose the rib option. We click on this line we created before, and now look. When we click on it and choose enter, it created like a sample rib for us and is waiting for the dimension of the rib to insert the proper value. Okay, according to our example, the value should be 14 millimeters. So we just click over here, yeah, and confirm by pressing enter. And as you see, using this method, we created the supporting structure of a rib, yeah, in our model. So now it's exactly as we wanted before. Let's get the dimensions. We can measure it, so there is no problem. Okay, you see it's 14 millimeters. Yeah, 14. Okay, yeah. And we're gonna hide them again so they're not getting away, and also we're gonna hide the newly created plane 4 because we are not gonna need it anymore during this exercise. Okay, So we're almost finished with this project, with this tutorial. Let's continue. Okay, after we created the rib, then we have to create 2 more holes, on this time on the bottom part of the object. And for this we're gonna use circles by center point. Okay, and the diameter of our holes should be 15.2 millimeters, and they have to be in the specific places. Yeah, so the dimension between the center points of the holes should be 42 millimeters, and from the left and the right side it should be 14, and 34 from the base up. Okay, so how we do that? Okay, we go back to our object, we move to the top, so we're like this. Okay, and now we're gonna create 2 holes. We have to lock on the plane, this time in this one, and we're gonna create 1 and 2. Okay, we're gonna measure them by smart dimension. Both of them have to have 15.2, so we edit 15.2. Second one also 15.2. Okay, and now they should be in the same axis, so we're gonna use option this one, horizontal vertical. We click this one and we click this one, and as you see, they centered each other, so they're now in the same area. Now we can measure the place from the center of the first one. Okay, so let's do this and this. Yeah, and this have to be, according to our project, 42 millimeters. So we can edit it 42 and enter. And as you see, they moved, yeah, to this specific place. Now I'm gonna sketch a line from the center of first one to center of the second one. Okay, and now I will align them with the center of the whole object. So I do like this, and I choose this, and I choose this. Okay, as you see, now they're aligned, centered to our object. And then again, the last dimension I need to take care of. So if everything's according to our plan, this should be now 14. 1 second. This one should be 14. Yeah, it's correct. So the dimensions from the both sides are correct. And now the last thing I need to do is to create the last dimension, this one, that's supposed to be 34 millimeters, and confirm by enter. And as you see, they both moved to the correct values. And if I look here, yeah, I made exactly the same 2 objects according to those dimensions. Yeah, the last thing I need to do is to extrude them throughout from the bottom part. Yeah, so when I get back, I move it at the angle again. Okay, I click inside, holding the shift button so it highlights both of them. I press the down arrow and extrude them both down, confirm by clicking. And as you see, when I move it around in 3D, you see the objects, the holes, are extracted throughout the object on the bottom part according to our dimensions. Okay. Just to add one more thing, the main options to measure detail is smart dimension and distance between. They're most often used. But in most cases, smart dimension is just enough to measure any arcs, any length, height, or depth. So it's very useful to use the smart dimension options. And as you see, we now got to the very end of our object because we have our 3D model ready. So exactly as you see in this tutorial that I created, the 3D object is now ready. We're gonna unclick the PMI, and once you click the PMI, you can see all the dimensions we created before, and check them and also edit them. But for now, we're gonna just unclick it. You can zoom in and out of it. You can rotate it 360 degrees. Yeah. And now the coolest part is that if we press the main option button and we save it, there is an option to save it as an STL file. Okay. If we save it by the STL file, we name it 3D printing example object and save it to our desktop. Okay, we can choose options, choose millimeters, whatever you like. I'm gonna choose millimeters for now. The cool part is once we save it, okay, so the exact same object, 3D object, is now saved in this file. Okay, this STL file I can transfer directly to the 3D printing software and print it one-to-one, the same dimension, the same shapes on the 3D printer using the 3D printing software. Yeah. So what's the conclusion? Basically, whatever you can draw and create 3D objects from in Solid Edge, you can then later save as an STL file, and you can directly print it, and you're gonna have like a physical model in your hand from the object that you have in the program over here. So I can create a model, a physical object, one-to-one on the 3D printer, exactly the same as this one, with exactly the same measurements as over here. Okay. So that will be the end of our tutorial. I hope you find it useful. And I wish you happy creating and all the best, and then drawing, creating 3D models and 3D printing your favorite parts and examples. I wish you all the best and thank you for joining me to this tutorial.